All right, so I think that's most of you settled. Welcome to this talk. So I'm Mike Krus. I work for a company called QtDay. We sponsor the event. We have a booth outside, so you can come and see me after. And what I am going to talk right now is how do you use Qt and how do you integrate 3D content with your regular 2D applications. So it's a problem that's more and more common. A lot of you will have been given 3D content or have clients who will want to integrate 3D content into their application. And what I would talk to is what are the problems that you may encounter when you have to do this kind of thing. So I'm not talking about scientific 3D applications, that kind of thing. It's more about models that you want to integrate into your applications. Typical example is going to be the car demonstrator. So it might be an application that runs on the actual car that you might have on the dashboard, but it might be also an application that you use on a tablet or something like that to show some 3D content that you want to interact with. So such an example of an application here. So this was a demo that we did a few years ago. This uses Qt3D. So Qt3D is a module from Qt to do the 3D rendering. So we use Qt3D to load up the model, render it on the screen, and then we overlay on top of it some Qt Quick user interface. Okay, so this is running in demo mode, but I can come and I can interact with it. I can spin the model, have a look at it on the various angles, and then there's this Qt Quick interface that I can open up here. I can change, for example, I can make the wheels spin like that. So do some animations with the model. And then, that's not the one I wanted. This is the one here. No, actually, it was the top one. And here, I can trigger some other animations, for example, to open the hood or open the car doors like that. Okay? So how do you mix these 3D models with the 2D UI, and what are the problems that you may encounter when you try and do that? Okay? So typically, when you have this kind of problem, there's two major workflows that we try and represent on this slide that's probably a little overloaded. Just very briefly so you understand it, there's a top part and a bottom part, and they represent the very two different set of techniques that you can use in order to produce this kind of application. So the top part is to use basically a specific tool that helps you do that, okay? Example of such tools are things like Unity, Kanzi. Who here has heard of Kanzi? A few people. So Kanzi is a tool that is used to basically, all of these are tools that you can load up some module, make the scene look beautiful, customize materials, then build things like animations on it and things like that. They will produce an intermediate representation of this data, and they will come with a piece of runtime that you then link into your application, and that will load that and run whatever animations you created in the design tool. Okay? So they're quite nice because they have a design tool that lets you quite easily create some nice models, do these kinds of animation that we just saw, and then they have a runtime which loads this up and lets you link it into your application. Okay, so they're quite good to really get you going easily. Unity is the game engine. It's used a lot in a lot of places outside the gaming domain. A lot of car manufacturers use it for some of their demos and things like that. Kanzi is very used in the car automotive industry. Qt3D Studio is probably the most recent addition to that kind of tool. Comes with a very simple editor, very easy to pick up and do some quick prototyping and do things, some nice models and integrate them into your application. Now, the main problem with these kinds of things is that they come with their own authoring tool, which is not something that a 3D model designer is used to. So the 3D model designers, the people whose job it is to do 3D models, they will use things like Maya They will use things like 3D Studio Max. They will use things like Blender, which are professional tools that are designed to do 3D models and make them look nice and create some fancy animations, have some nice panning of the camera and do all these kind of things. And 3D modelers, that's the things that they want to use because they can do really nice things. However, you can't go directly from those tools into your own applications. So these tools like Unity and Kanzi and Qt3D Studio, they have their own editors and they have their own intermediate format and their own runtime. So that's the other limitation, is that you are constrained by whatever the runtime gives you. Okay? So for example, in the case of Qt3D Studio, it comes with a really nice runtime that makes it very easy to take a model, integrate it into your Qt Quick application. Internally, it uses Qt3D to do the rendering. However, it hides it completely. So if your application already does 3D rendering, it's really complicated to mix a scene from Qt3D Studio with your 3D rendering because Qt3D Studio hides the Qt3D part of it completely. Okay, so all of these tools and some of the other tools like Kanzi, for example, it knows nothing about Qt. So if you want to integrate a 2D UI with a Kanzi model, then there's a lot more work that you need to do the integration. Okay, so that's why in order to get a much deeper integration, usually we will use the second way, that's sort of the bottom part of this slide, is to do it more the programmatic way, okay? So we want to basically be able to load the model in our program and then render it ourselves, probably using Qt3D. So Qt3D is a module from Qt. It's one of the most recent additions to Qt that's been around for a while now. It has a C++ and a QML API. It's based on a scene graph, so you build a hierarchy of your scene. I'm not going to go into too much detail, but it knows how to basically load the models. It knows how to do the rendering of the models. It knows about things like material, which gives the appearance to your model. It does something called PBR, which is physics-based rendering, which was used a lot to do these realistic things that look really like metal or like plastic and things like that. Or you can write your own renderer if you want to. It has also an animation engine and so on. And it's all part of Qt, so it's really easy to integrate with your application. In particular, it comes with, when it comes to integrate it with Qt Quick, so it comes with two QML components. There's Scene 3D, which basically lets you take a 3D scene and put it inside a Qt Quick application. And then you can use property bindings to access the properties of the loaded scene. And there's Scene 2D, which does the other way around. It takes a Qt Quick scene and lets you integrate it into a 3D model. So for example, if you have a model of a car and you had a flat surface like on the dashboard, you can render a Qt Quick scene on the surface of the dashboard and interact with it. Okay? So you can take your 2D scene and have it directly embedded in your model. And that's, for those of you who've done this kind of things before, that's the hard thing to do, trademark. You know? But all of that comes out of the box with Qt3D. So when you use Qt3D to build your application, that's basically what we did for this car demo. So if I show you the code very quickly for the car demo, it's made up of a few dozens of QML files. And basically all these files that you see here, I don't know how many there are, maybe 30 or so files. These files are just for rendering the car. Okay, so it's a lot of work to do that. Basically, what we do is that we take the model that was made by the designer, we export it into intermediate files, and then we need to write code to load all those files, assemble them into a scene, and then have that scene rendered. Okay, so the car, for example, here, I think the top level one is this. So I'm not sure how much of this you can read, but it doesn't really matter. Mostly the important bit you can see is here. It's loading all the different bits of the car. So for example, that's the back left wheel. It needs to load all these models, okay? Because that's what the wheel is made of. It's made of these little OBJ files, which is a very simple way of describing 3D models, just the geometry, no materials, no appearance to them, and they get all loaded. So you have to write a lot of code to basically load up your model. The advantage of that is that once it's loaded, you can do pretty much what you want with it. You don't have a black box. You have all the pieces, but it's a lot of work for you to do. So for example, if I go and look at the doors, which are loaded, there's the left door here. I forget where the two part. Car doors here. So this basically, these are the two doors of the car in the demo I just saw. So there's the left door here, and there's the right door here. So there's a lot of, and then the left door is basically all of these meshes loaded up, and then given the right materials. So when you do 3D models, you need to load up geometry, and you need to define materials which give the appearance of glass, the appearance of metal, the appearance of plastic, and so on. And then you need to assemble that. So all of this is a relatively large amount of code to take your model in and load it up into your application. Okay, and then the other thing you have to do as a developer, say that the designer has conceived these animations to open the door, well, you have to write some code to reproduce those animations yourself. Okay, so if you look at the car doors again, you'll see here there's a transform component, which is basically what you use to rotate the doors. In order to do a rotation in 3D, you need to rotate around an axis, so you need to be able to give the point of that axis on the direction, and then that basically rotates the car around this axis. Which means you need to be told about this, exactly where that axis is. So the designer will give you that, or you need to be able to use a 3D tool to find out what that point is. Okay? So you have to write a lot of code to go and do all these animations. Okay, so when we did this demo a few years ago, 2 or 3 years ago now, we thought, okay, it's a lot of work, but this is all done in Qt3D and QML. Okay, so this is a couple of thousand lines of code. For those of you who would have done that more traditional C++ 3D rendering libraries, you will probably know that it could potentially take a lot more work than this. So this is actually already relatively good. But it's still a bit of a pain to go and have to write all these codes with all these animations and all the plumbing to link basically the flip of the switch in QML to the fact that this transformation here gets modified to do your rotation. You have to do all this plumbing yourself. Okay? And then maybe you hire another designer, and you have a designer now which has taste, and rather than having a Dodge Viper, it wants a Ferrari. In this case, you have to rewrite all your code. Okay, so a different model is going to be made of different files. All these transformation points are all going to be in different places. So you have to adapt all your code. Okay? So, you can do it. It's really powerful because you have full control of the integration of your 3D model with your QQuick application. But it's not necessarily a very nice thing that you want to do for a living and write all this code all the time. Which brings us to, basically the major issues with that is, lots of code. A lot of things get lost in the translation, basically, because you're having to reinterpret what the designer created. You have to reinterpret that in code. A lot of things get lost in the translation. There's also quite a lot of constraints that the designer is not necessarily aware of, when it comes to actually render interactively in Qt3D. It might give you a very detailed model that actually is way too slow to render on your target. So you might have to go and simplify the model and do things to it and things like that. Might be too many textures. And as I said just before, the cost of updating the 3D scene is really high because you have to re-implement basically loading a new model. Which basically led us to create a new library that we released at the end of last year called Quasar. So Quasar is basically a library which sits on top of Qt3D and is made up of three main components. So there's some components that are integrated in professional 3D design tools. So think Blender, think 3ds Max. That's plugins that we write for those two. Eventually, we'll probably write one for Maya also. So the professional tools that the designers know how to use and are very efficient how to use. Okay, so the second bit is, these plugins will basically export the data in a special format that I'll come back into more detail soon. The second bit is a runtime component that basically lets you load these files and lets you do the integration with QQuick in a very easy way and a more declarative way. And finally, it comes with a set of tools that are used by both the designer and the programmer to be able to review the shared model and have an understanding about how the designer will use them to see how the final model will look in the application. And the programmer will use it to basically query the model, find out what the name of the various models are, what kind of animations are embedded, and so on. So what I'm going to do for the rest of my talk is talk about these three components inside that are provided by Quasar. Okay, so the first thing that we realize is that we want the designers to be able to use the tools that they are used to. So the professional modeling tools not have to learn a new tool like Unity or Kanzi or Qt3D Studio. So basically here the designer is going to be the tools he's used to model all the objects, do all the material, so paint some nice textures on the scene and so on. And also some of the things that are very important is animations. So all these animations about the opening of the bonnet and the door, you might think, okay, there's only one way of opening a door, but actually having a proper animation that starts slowly and then accelerates and slows down, have some other easing factors. It's very important, the designer, for something to look natural. Another thing that's quite important is things like animating the point of view. So a lot of the thing that the designer does is that he does a nice model of a car, but actually he knows that the better angle to look at that car is like that, not like that, and so on. So he wants to be able to control where the car, the point of view, whether you're looking at the car. Okay, so you define cameras, and you can actually do animations on the movement of that cameras to do some cinematic effects and so on. Okay, so that's basically what the designer wants to do, which leads us to how do we get this into our application. So basically, there's an open standard for a file format called GLTF. Okay, which is designed by an organization called Krus. They're responsible for a lot of 3D stuff. So they're responsible for the specifications of OpenGL, Vulkan, and a lot of related to the technologies, things related to virtual reality and so on. GLTF is the GL transfer format file. It's basically a open specification. It's adopted by a lot of big names. Microsoft, Google, and Facebook use them. So if you see 3D models inside Facebook, they usually come as GLTF files and so on. It's a specification is designed to be relatively simple and compact. So it comes with a JSON file that describes a structure, and then usually one big binary file that contains all the actual data. So when you send a model across, you need to give lots of things like coordinates, all the information about triangles, things like materials, textures, and things like that. These can be huge. Okay? And all of these are encoded in binary files in a format that actually makes them very efficient to load and very efficient to render. So they come out in a format that's actually ready to use for you writing a rendering application. Okay, and it's not just about the model. It actually contains a lot of information about materials. It contains animation about animations. So you can do these very simple animations like in the car, which is just basically what's called rigid body animation, which is just moving an object by rotating it and so on. But it also does skeletal animations, so animate bodies. So when you animate bodies, it's not just moving an object. The object can be deformed itself, can be deformed as you animate. You might have the shape of the arm will change and so on. All of that's supported in GLTF. And that's kind of thing that comes out of the professional design tools. So the kind of thing you can't do in Kanzi or other such tools like that. Okay, and the last bit about GLTF is that it's extendable, so it comes a way of adding new features to it, and I'll come to that in just a little bit. Okay, so the first thing that you need to do when you want to integrate a model from that's created in one of those tools like Blender is to export it to GLTF. All the major tools come with GLTF exporters because it's a popular format. So 3ds Max has one, Blender has one, Maya has one. A lot of the other tools now are having their own GLTF exporter, and because it's a norm, then basically you can just quickly rely on the format being these formats being correct. What we have done as part of Quasar is to take two popular exporters and just basically customize them for some of our extensions, and I'll come back to show you that later on. I was going to show you a little bit about Blender. Unfortunately, on a VGA display, Blender looks like that, so there's really not much room for me to work. But basically, this is an authoring tool. You do the model, you can create animations. You can then go and play those animations that are all inside the file. I can then pick a camera, and then if I play my animation again, normally, I missed the camera. Anyway, I'm not going to spend too much time on Blender here. I'm not a designer. I don't know this tool really well. But that's kind of the professional tool that a designer will use to produce the models. And then we have some extension here, so you can do file, export, and it's disappeared. Normally you would see Quasar exporter here. Not quite sure what happened. Demo effect was shy. Anyway, so you export the GLTF. You can use the regular one, or you can use a customized Quasar one. The Quasar one will basically add support for a couple of extensions I'll mention later on. Once you have your GLTF file, so this is a very efficient little file format, you need to load it up in your application and work with it. And you basically do that very easy, writing a bit of QML. So Quasar comes with a C++ and a QML API, so you can use whichever you prefer for your application. The examples I'm going to show today are just QML. So if I go to Creator here, I can go and create a new project for a Quasar application. So we ship some templates for Qt Creator to create some projects. Do here, I can have it open a file, for example, this GLTF water bottle. I can pick the right kit. And normally, fingers crossed, if I build and run, yeah. So basically here, you can see the model of a loaded water bottle. You'll notice it's darker than the one in the slide. Two reasons. One is the projector. Second one is the fact that there's no environment map, so there's no scene around this to give it some light. Okay? But basically here, really easy to load up the model. So if I look a little bit at the generated QML, so Quasar relies entirely on Qt3D, but it doesn't hide it. Okay, so you have access to Qt3D, and you can mix and match your Qt3D, your own scenes, with the Quasar managed content. So here we import all Qt3D, we import Quasar. The root in this case is a entity called scene entity, which is basically there to do some bookkeeping about what's inside the loaded files. I'll come back to that later on. Part of Qt3D, you need to define something called a forward renderer, which basically controls how things get displayed. So it's not about what is displayed, it's how it's displayed. Don't go into too much detail. We need to specify a camera, which specifies where we are looking at the object from. The camera controller is used to respond to mouse event to move the camera. And then we have our GLTF importer here, which is responsible for loading the GLTF file into the scene. And basically, then that gets rendered by Qt3D. So the core of Quasar, in terms of integrating with your application, is this importer here, and then the root scene, the entity. Okay? So really, really easy to load up model and get it on the screen. And you can do that in just a few lines of code. The tricky bit then becomes, well, the interesting bit for you as a developer is how do I access the various parts of my model? How do I go and trigger animations? How can I find the object that is the hood of my model, of my car, for example? Okay? And that's where Quasar comes, the runtime bit comes with a lot of little utilities that makes the integration a lot easier to do than the previous car demo that we just saw. Okay, so the runtime, really easy, scene entity, and the importer. So the importer, I just mentioned it. All the data gets parented from the importer, which means you can then apply transformations to your entire model. The source is a URL with a few limitations. For now, we only support local content, so not stuff downloaded from the web, and does not support binary GLTF, which is a different version of the file format. It will once somebody approves my patch, okay, which is pending on GitHub. And then the scene entity here that I just mentioned, that is basically the scene entity, its role is there to record all the objects that are loaded inside of the GLTF. Now, one of the things you can do inside the editing, so if I show you Blender very quickly, you'll see on the left-hand side here, these are all the objects that are in the scene organized in a hierarchy, and they are named. Okay? So basically, this name is what we're going to be able to use to access from the runtime the relevant objects that you want to access from the runtime. Okay? So in order to basically collect this information, the scene entity organizes things in collections, which I think I talk about here. So a collection basically is just an array of named objects. There's actually several collections that are hang off the scene entity. And they're basically based on types of objects. So you have collections for materials. You're going to have collections for meshes. You're going to have connections for entities. So an entity is basically a combination of a mesh and a material, or maybe several meshes all organized into one entity. Okay, so that's what appears in the side that the designer is going to name the objects properly. Okay, and they become all available at runtimes through these connections, which means then you can look up the connection at runtime as a developer, write some code that looks up the connection and then accesses a mesh, for example, or a camera to be able to set the camera to the one that's in the file, and so on. Okay, so that's one of the key roles of Quasar, the runtime bit, is to be able to organize this collection of information and let you poke inside the loaded model. So basically the contract between the designer and the developer in this case is based on those names. When the designer delivers the model, it will basically tell you the car hood is called hood body or something like that. So that's the name of the object. We'll see at the end, one of the tools lets you inspect the model and see what the various names are, pick on an object and find out what the name are and so on. But then the key advantage of that is that if the designer, if you hire one with taste again, that chucks away the Dodge Viper and puts in a Ferrari, as long as the parts have the same name, your code doesn't need to change whatsoever. Because if the door is called door, then it's not going to change between the two models. Okay? If you have more doors, then maybe you have a problem. So how do you access these at runtime? There's the use of collections. So they're basically arrays of objects, which means you can query them by name and so on. Write some imperative code to go and iterate through the arrays to find the names and then look up an object by name and do something to it. A nicer way of doing it is by using an item called asset, which basically here it's a bit like a binding in QML, for those of you who know QML. So an asset, you give it a collection. So here in this case, I'm interested in looking at cameras, and you give it a name. And then basically the asset has a property called node, which points to the loaded asset with that name, okay? So if you load a file that has a camera called sweepCam, then the node property of the asset will point to that camera. Otherwise, it will be nil or undefined, okay? So you automatically have a nice way of using bindings in order to load up what gets displayed. So basically, if I show you now let's quit Blender, the Quasar version of the car demo. So I run it here. So this is the demo that, for those of you who've been by our booth already, it's running on a Tegra board, but I'm running here on the display. Ignore the menu on the side. The scaling for this display is completely off. But basically here, this is a model created in Blender, exported to GLTF, loaded up using Quasar, and basically with some UI, which is different, but does the same similar things that the previous demo we saw. So I can come here and toggle animations to open the hood, or to open doors, or to change the wheel speed, and so on. And do some, I can also come and customize the material. So I can change the color. Now I'm colorblind, so don't trust me where to pick the color of your car. But basically you get the idea, okay? And the code here, as you will see in this application, is considerably shorter than in the previous example, okay? The 3D, the main scene is basically just this one file which is 250 lines long, okay? So that's what loads the model and does the linking up of properties to let you then do bindings to interact with it using QML. Okay, so no complicated setup, lots of code to write. It's all easy here. So we have our scene entity. We have the importer, which I think it's at the very bottom. That loads up the Dodge Viper model. We have a camera controller, and we have a main camera here. So camera controller is there to control the movements, the mouse events to control the movements of the camera when you interact with it. And then one of the things that you want to do, so if I run the application, you would have seen this sweeping camera animation. So basically, what I want to do is to select that camera, and then I want to start animations. So to select the camera, what I'm going to do is my asset node here. I'm interested in looking up the camera collection for this name. And then basically, I have I can use the node property of my asset loader and do some bindings. So here I have a binding to basically set the aspect ratio of the window to property so the model doesn't get distorted. That's a detail. The main thing that's important is to tell the forward renderer which camera to use. Okay? So in the case of having an animation and actually having found my asset called SweepCam, then that's the camera I'm going to use. Otherwise, I'm going to use main camera, which is kind of our fallback camera here that we've defined in here. Okay? So finding cameras which have been designed, created by the designer and stored inside the GLTF file is really easy. And it's the kind of thing that designer care about, that to control where the object is seen from and so on. Okay? And then you can find similar things for doing animations. So if I go back to my slides, using assets. So GLTF can store animations. An animation is basically made of two parts. There's something called clips, which is basically values of things like positions or rotations at different moments in time. And then basically you would interpolate across these values through time. And then there's something called mappers, which is a mapping of these values to actual properties. Sorry, lost my train of thought. So yes, the actual properties that need to be modified. So basically, which transformation needs to be modified by the animated values. Okay? What you need to do is to actually play the animation, is link the two together and give them to an animation player that would actually trigger the animation. This is what the animation class does. And you can see it here, for example, for the left door and the right door. And the hood animations, where basically we use the animation player, and we need to look up the clip and the mapping data from the GLTF file, and again, we do that by name, okay? Because the designer is going to name the animations, and that's how you then look up the thing. And then basically using animation player, you can start and stop the animations very easily. The wheels are a bit more complicated because there's lots of different parts that turn, so we just use a node instantiator to create several animation players for each part, and then we're just going to start them all together or stop them all together. Okay? So again, very easy to access animation and trigger those animations that were created by the designer. Quasar supports a couple of popular extensions. One of them is called Draco. Draco is a mesh compression library designed by Google. So the idea is to compact, so meshes can be really dense and big data. The Draco mesh compression makes this more compact. It's not a lossless compression, so it actually does remove details from the mesh. But you can control how much you want to remove and so on. And basically, in the case of the car model, the raw GLTF file is 16 megabytes. The compressed one that we use in the demo is 2.6 megabytes, okay? Which is a huge gain, a lot less data to load up from if you have working with slow disks, like it's often the case on embedded devices. And it's also very efficient to decompress. So usually the balance between, for compression is that you trade disk space against computational space because you need to decompress, but the decompression here is very efficient. There's also support for DDS files, which are compressed textures. I won't talk about too much. We have our own extension that we'd added to GLTF layers. So in our plugin that we created for Blender and for 3ds Max has a way of assigning objects to different layers. So for those of you who use things like Photoshop, it's basically a way of grouping object into different layers, which means then at runtime you can use a Qt3D object called a layer filter to basically show and hide various parts of the scene very efficiently. Okay, so that's an extension that we wrote that's only available in the GLTF file if you use our exporters rather than the generic ones. Part of Qt3D is PBR material, so physics-based rendering, which is a way of basically controlling the appearance of your surfaces and controlling if you want something that looks very shiny and metallic or shiny and plastic or dull, sort of like if it's powdered or had the polish removed and so on. So there's a PBR material in Quasar, which is slightly different from the one that comes with Qt3D by default. It's slightly more advanced in order to support some of the required features for GLTF. It also comes, the rendering also comes with effects, so you can do things like blurring your scene, Gaussian blur, or do threshold rendering. It also does opacity mask. So if I show you the car demo again, right here. There's an opacity mask here, and basically it's a level of just a simple texture with just gray levels. And basically, where it's black, you see the scene. Where it's white, you see the background of the scene. So here we have these little triangles moving about, which are just QML items, which is behind my scene. And basically, it lets you, the opacity mask lets you punch a hole through your 3D scene to see whatever is behind. So it makes you like integrating 3D models in things that are not just rectangular views. Car clusters tend to have very complex shapes. So if you want to render a 3D model into a complex shape, you can use an opacity mask for that. So that's basically all that's most of the things that are in the runtime. If you want more detail, come and see me at the booth. The last thing, kind of things that comes with Quasar is a couple of tools to let the designer and the programmer review the model. So we ship something called the Asset Pipeline Editor, which is basically, it started off as just a glorified GLTF viewer. But basically here, I can come and open my car model and see it in here. And then in side panel here, you can see all the collections, and you can see all the objects that are defined in here. And for example, if I want to find out what the name of the mesh for the hood is, I just click on the hood, and basically you see the hood is hood body 0. Okay, so that's the name of the object in the mesh collection that contains this. If I shift-click, or command, control-click, I forget, you can look up materials and you can look up entities. Okay, so that lets you, the designer, check that the model actually renders properly, that all the names are correct, and it lets the programmer find out what the names are. And you can also preview animations and things like that. And that's basically using these tools, you can find out the name of things. For example, if I wanted to take my car scene and say I wanted to, if I clicked on the hood, I wanted to open it. I want to add some interaction. So here in my scene, the object to handle clicking in Qt3D is called object picker. So let's click hood picker. And when it's triggered, when you click on the hood, I want to basically toggle the hood animation. So there's a property at the root called open hoods. I can just do open hood equals not open hood to trigger the animation. So that's my object picker. That's what I need to Qt3D, so to do some picking. I need to attach it to an object. And that's the object that I need to click on to do that. So in order to do this, I'm going to do Quasar asset. I'm interested in the entity collection, which is basically the nodes in the scene. And the name is, I hope, if I remember correctly, just hood. And then basically, if when the model is loaded, if there is an entity called hood, then the node property of the asset will be pointing to that. So on node change, if indeed my node is valid, I can do node dot components dot, if I could type, components dot push and my hood picker. Okay? So normally, if I run the right application, so normally now, in this case, I've loaded the car, and when it's got loaded, it found the hood object, and it's added the object picker. So when I click on the hood, it toggles the car. So you can see how really easy it is to add Qt3D properties or do the bindings with the model and so on. Okay, so this tool here, the asset pipeline editor is really useful to do the kind of thing. It also can do the Draco compression. So if you want to compress the model, it can do that. There's also a another tool, a command line tool, to do a manipulation on the GLTF file. The idea for that is to basically be able to integrate the manipulation of the GLTF file, so the compression or embedding all the textures into the one file and so on, to do that on the command line as part of your CI, to automate all this kind of process and so on. So time is up, so just to conclude, remember, Quasar, these basically three parts, the content creation plugins, the asset pipeline runtime, and the tools. They're available, they're open source, and either GPL or, for the runtime, it's AGPL or commercial for using Quasar, and the rest of the tools, licensing here. Okay, it's all on GitHub. If you have more questions, I think 9 is the time for questions. Otherwise, I will be on the booth for the next 2 days. Thank you very much.
Thank you very much, Mike. Yeah. Any questions? Don't be shy. Any question? Yeah.
So I actually have two questions. The first one is, does the GLTF exporter also work with Blender 2.8, which pretty much breaks the API?
I haven't tried.
Okay.
Yeah, I got shy of installing it before the presentation, so I didn't try it. But I don't think it does. I think the exporter APIs doesn't change too much.
I don't know. It's just like Blender 2.8 is
Yeah.
X times better than
Yeah.
the previous versions. So, and the second question is, does it work with Qt for WebAssembly? Have you tried it?
No, I haven't. If Qt3D, so this is purely on top of Qt3D, so if Qt3D works, so on top of WebAssembly, you get a slightly different version of OpenGL. It's ES2, I think, on top of WebAssembly. And so Quasar comes with ES2, which is the common version of OpenGL that ships on older mobile devices and a lot of embedded devices. That has limitations, and Quasar actually comes with special tools so it does all the rendering natively on ES2, and it has tools, because some of the environment maps that I didn't show, so when you put your scene inside an environment map, it gets light from whatever's in the environment. So the car I showed in the editor, you could see reflections of tree on the ground. That's because the car is rendered in an environment that has trees and sun and things like that. So these textures that represent the environment map, they have to be in a special format for ES2, and Quasar comes with a special tool to convert to that format. So we support ES2, which I believe is what WebAssembly relies on. I may be wrong, but I haven't tried it.
It would be a cool demo to have it
Yeah.
running a web browser. Okay, thank you very much.
You're welcome.
Any other question? Yeah.
Okay, I actually have two questions. One, the difference in the licensing scheme from GPL and commercial.
Yeah.
And the second one is if you can interact with the 3D model, for example, to let the user put a sticker on, for example, on the surface, on a door or on the hood, or, for example, drag and drop, let the user click on the hood and half open it. So
Yeah.
variations on the animations made by the designer.
Sorry, first question, licensing.
Yeah, so I briefly saw in the slide that is commercial and AGPL.
Yeah.
What is
So AGPL is same thing as GPL, except it has a restriction onto running the binary on things like servers. It was designed to stop people doing web-based servers and services using GPL software. So basically, you can't take our asset processor and run it for free as a service that you would resell. You would need to get a license from us to do that.
but the tool capability is the same.
Yes, the capabilities are exactly the same. It's purely, it's like most of Qt, it's purely a different licensing. So. And then there's commercial for if you need to basically embed this in your applications and that you ship and things like that.
Regarding the second question?
So second questions was kind of
interactions customizable by the user.
So they're kind of two different things. In this case, the interactions we did in those demos is just triggering ready-made animations. Because this is built on top of Qt3D and it doesn't hide anything from Qt3D, you can just use the normal features of Qt3D, and you could actually click on an object and write some code that basically track the mouse of the movement of the mouse, transform that into translations or on the actual object, and move your object. Okay. I have actually a little demo that has a QML UI to let you edit the rotation of an object, for example. So that you can completely do these kind of things, but that doesn't come from Quasar, it comes from Qt3D. So you have to write the code to do that. We don't ship things like manipulators. So manipulators tend to be ready-made objects that get embedded in the scene and help you. Because moving an object in Qt3D, you think it's in 3D, sorry, in general, you think it's very easy, but it's actually really complicated once it's on the screen. Moving a glass for me like that in 3D space is easy, but dragging a mouse on the screen to precisely put the glass where I wanted my scene is actually quite complicated. So usually use something called manipulators that let you control the movement. So we don't ship any of that. You would have to build your own. But you can do it because Qt3D is there, and Qt3D has all the tool blocks to help you do that.
Okay, thank you.
Okay, I think the time is up. So thank you again, Mike.
Welcome. Thank you.
Thank you.